Shiro. I'm a seismologist here at the Hawaiian Volcano Observatory in Hawaii.
Oh, very nice. And what do you do here?
I help manage the seismic network, make sure all of our stations are running that monitor the volcano and detect earthquakes.
Very good. So we had a few questions from some of the students. One of them asked, Piper, do volcanic eruptions cause earthquakes, or do earthquakes cause eruptions?
Well, that's a good question, Piper. You know, earthquakes around the volcanoes here tend to precede the eruptions, at least they can. But there are two main types of earthquakes that we deal with, and there are a little bit different causes for them. So one type, the volcanic earthquakes, are associated with magma being injected into the rock. As you might imagine, that puts stresses on the rock. It can cause fracturing, which leads to earthquakes, and that's why these earthquakes can be a good indicator of the eruptive activity and sometimes even show us where it may happen. So that's one type. Those tend to be the smaller earthquakes overall. The other type of earthquake are called tectonic earthquakes. Tectonic earthquakes can happen really at any time, and they're due to the weight of the island pressing down and moving along existing faults within the state, within the island. So those tend to be larger. They can build up more stress over time, tend to be more damaging, but they can also be small too. So volcanic tectonic earthquakes happen here. Some are related to volcanoes and some aren't.
Emmy and Sean were wondering what happens to a volcano if there was an earthquake?
Oh, well, so Amy, Sean, when an earthquake happens, it can cause slippage along the fault, it can cause movement underground, and in some cases at the surface as well. It doesn't really affect the volcano itself, so if the volcano is erupting, it's not necessarily going to be affected by the earthquake, although in some cases there have been earthquakes large enough that have occurred where the magma system may get cut off slightly and it may affect where it emits out of the ground. But by and large, the volcano does its thing, and the earthquakes are a response to it here.
No one wanted to mention their name to this one, but someone asked, can you stop an earthquake?
Can you stop an earthquake? No, I wish we could. So, you know, the Earth is very powerful. The forces brewing inside our planet are huge, and people just cannot mess with those forces. So, you can be knowledgeable about earthquakes, you can know the signs, you can have a plan for what to do. Drop, cover, hold on. When an earthquake occurs, get under a table, you can save yourself. But you can't stop the earthquake. You can only mitigate the effects of it. So, have your buildings built well, for example, that kind of thing. You can't stop it.
Why do earthquakes happen in Hawaii since they're not on a fault line? And Theron has asked that question.
Yeah, so Theron, I think you know that the Earth is divided up into a number of plates. This is called plate tectonics, And these plates move around, they shift, and it causes most of the world's earthquakes, as well as volcanoes, tsunamis, things like this. Hawaii is in the middle of one of these plates, in the Pacific plate, but we're under a hot spot. So a hot spot's underneath us, coming up, Hawaii's riding above that, and this causes the volcanoes that are here. This causes magma to melt beneath the surface, and over time, the earthquakes occur as a result too. So that's why the earthquakes happen here. We have the hot spot. Other notable hot spots occur, places like Yellowstone, for example, Iceland. Okay, there are other places around the world that are analogous to this. And now there are small faults within Hawaii where earthquakes do occur, where basically you have the weight of the island, the weight of all these volcanoes pushing down the Earth's crust kind of causes movement and cracks, and any crack underground is a fault. It doesn't have to be a huge plate tectonic fault, it can be local ones too.
Just with that, to continue on, this is my own question.
Okay.
Is that why there would be earthquakes in Alberta then? Because we get them occasionally. So if we're not on a fault, because it's my understanding that we're in the middle of a plate.
Sure. So generally speaking, earthquakes either interplate or intraplate. Okay. Interplate is between the plates. This is the most common type of earthquake in the world, where the plates rub against each other, either side to side or up and down like this, or even pulling apart. This can cause earthquakes. Now, intraplate earthquakes, like we have here in Hawaii, and also like they have in Alberta, are caused by other stresses on the plate. So sometimes, like in Hawaii, it's magma being pushed in, making volcanoes and moving around the rocks. In other spots, it can be an injection of water in the subsurface. This is called fracking. It's very much in the news these days. But there can be other pre-existing stresses. For example, the New Madcom seismic zone in the central U.S. is known to have a lot of small earthquakes because way back in history there was basically a failed rift where the crust tried to pull apart and didn't quite do it. Now there's a weak spot there. I don't know exactly in Alberta what the situation is, but intraplate earthquakes are common. They occur for different reasons. The crust gets squeezed and pushed around enough. It has weaknesses inside too.
Sure. Okay. Thank you.
Yeah.
Maddie had a question about dormant volcanoes, and we talked a little bit about dormant and not dormant before we started filming, but if you could just speak to, can a dormant volcano or an inactive volcano become active again, and what would cause that to happen?
Here in the USGS, we classify volcanoes as active if they've erupted in the past 10,000 years. Okay? So if it's been longer than that, then we can bump it to the inactive category. In Hawaii, for example, there are 6 active volcanoes officially because they erupted within 10,000 years. But only one of these is actually actively erupting today, Kilauea, where we are today. So can an earthquake that is not erupting, a volcano that is not erupting, start erupting? The answer is yes, of course. And one of the reasons why the classification system is that way is so that you're not caught off guard, so we can monitor these other volcanoes and know that they may erupt again. So whether you use the word dormant or not depends on the current lexicon, but yes, a volcano can change from one status to another. Because
your focus is mostly earthquakes, but could you answer Aaron's question about what is the top speed that lava can flow?
Well, let me just ramble about it. No, I don't know, but I can tell you in Hawaii, we have a shield volcano in Hawaii. Yes. This tends to make very low, broad volcanoes. It's very benign, kind of slow-flowing flows. If anybody's gone out there and watched them, you can see the flow coming up, moving. It's very slow, much slower than you walk in Hawaii. Now, in other places where you have steeper volcanoes, the flows can be a lot faster. As you might imagine, gravity pulls it downhill much faster. So I'm going to say it depends on the situation, depends on the type of activity, how much force is pushing it out, how much gas is mixed with the lava, for example. And Hawaii, we tend to have very viscous kind of flows, which slows them down. But other places in the world are not as lucky. Now, there are occasional events here called fountain eruptions. Okay. You may have seen this really spew up hundreds, thousands of feet in the air in some cases. That's obviously moving fast in the air, and as it transports, it falls down. But again, once it falls, it doesn't move that fast to the ground.
Okay. Ethan has a question. Can a seismograph pick up car vibrations if you were driving on the road?
So that's a good question, Ethan. Seismographs these days are very sensitive, depends on the type, but many of them, most of them in fact, can pick up driving cars, foot traffic, people walking, construction, all kinds of activity that humans may cause. We call that cultural noise for our purposes on our instruments. This is one of the reasons why we want to locate them far away from population centers for people. We tend to put our instruments far in the field, away from those sources of noise and vibration, so that when we do receive signal, we know it's from an earthquake or some natural source. But having said that, many scientists monitor buildings, for example, in urban areas on purpose because they want to know how these structures respond to shaking, and therefore how can we improve them in the future. So it just depends on what your focus is and what you care about, but absolutely you can detect moving vehicles.
Okay, thank you.
What got you kind of interested in what you do in seismology?
I was thinking back what got me interested in seismology, and the first introduction I had to earthquakes was when I was in second grade. And I remember my county had an earthquake poster contest. It's called Be Quake Safe. And somehow I won the contest. And so I got to meet the mayor and go to this fancy lunch and got some prizes, and it made an impression upon me, I guess. And ever since then, I've always had an interest in earthquakes. But it really wasn't many years later, when I was in college, when I took my first geophysics class, that I just realized this is a really fun, exciting field to be in. And, I've always liked science. I've always been drawn, especially to physics and the physical sciences. But I've found that the earth sciences broadly are a really nice fit for me because it's a way to apply this type of theoretical knowledge to something that really matters. So, being safe from earthquakes and volcanoes, for example, really matters to people. And finding resources, water, things like this, all the things that earth scientists do to understand our planet and protect the planet is highly relevant to our daily lives, and it's a great way to apply science to something. So it was clear to me, through college and my classes that I took, that this is a great field. So here I am, And so you need to study science and math and get out there in the field and get dirty and explore and see what area you like the most. But I found earthquakes pretty interesting. It's a good way to combine computers if you're interested in computers and programming with geology. You can do a little both.